I've got a submission here from 2dogrc, trying to get rid of some shakes when doing a hard yaw 180. So good on you. You've solved the problem, or maybe gotten closer, you say, by raising your D on pitch and roll to 18 and 17, but it makes the motor sound funny, and D is way too high on the graph. Yep, it's never good to have the D gain so high that your motors start to get these micro oscillations. It may not damage them, but yeah, you just get that sound and they don't sound smooth, and just somewhere deep down inside you know it's not right, I guess. But yeah, so probably, hopefully, you can solve the problem without having to go to that length. Let's take a look at your logs. You've submitted 3 logs, and the title is the P and the D values on roll and pitch. So the first one we're going to look at is, oh, I can't, hang on. The first one we're going to look at is the D and the P values on roll and pitch. So I'm guessing, yeah, pitch, the P value of 1.4 and the D of 3 is the only thing that sort of makes sense. And you say you're using rewrite. No, you said you're using multi-weight. So, okay, so 1.4 is not too high on MW 2.3. I would have guessed that that was Lux float, but let's take a look at what we got and see if we can make sense of it. So let's look, we're tuning a yaw issue. So let's look, first of all, at your yaw axis and find places where you were doing something with your yaw. And so we can do that by zooming out and looking for places where the yaw gyro has some kind of an issue. Now this is already interesting to me. This may not even be related to your issue, but do you see that the I term on yaw has risen here very high? But look at the gyro. Notice that the gyro is flat. So the copter is not really yawing, but something is happening to create a yaw bias. Something is pushing the copter to make it want to yaw, either to the left or to the right. I don't know which one positive yaw term is. And the I term is having to rise to counteract that. And the I term is successfully doing that. That we're not yawing. The gyro line is flat. And then the opposite happens here. Coming out of this move, I see. You did a move, the I term got zeroed. So that's interesting. I'm really curious what you're doing here. Let's zoom in a little. The stick is centered. What were you doing? I see. Here we've got a couple little dropouts. Let's just play that back real quick. You blipped the stick somehow. I really wish I knew what position the copter was in. Is it tilted over here? You got 0 throttle. Oh, I see. I got you. You haven't raised the throttle yet, of course. You're on the ground. You're kind of blipping the throttle around, but you're still on the ground. And this raise in the I term is because this is, people talk about, oh, the motors spin up when I'm on the ground. Why do they do that? This is why. Notice that the I term is rising, but the gyro isn't moving because you're not flying yet. And therefore, the I term just rises and can't go anywhere. Okay, so never mind. Forget all that. I'm going to leave it in the recording because I think it's instructional to see, how the I term rises even though the gyro is not moving because you're not flying. I think that's instructional, but it doesn't actually have anything to do with your problem. So we'll keep moving. Okay, now we're flying. Now we're flying. Okay, things look a little more normal. And we do have these twitches here. 6.2, 6.4, 6.7, 7.1. These 0.2 second twitches. I can't remember if you, I don't think it was you who asked about this, these 0.2 second twitches. Is that a coincidence? Let's play that back. No, no, no. There's nothing that you're really doing with your sticks or anything. That's interesting. We'll keep that in mind. We're still looking for times when you really did a sharp yaw move. So here we see the yaw I term getting zeroed out. It doesn't look like you're doing that sharp of a move. What's your yaw rate? Well, 52 degrees per second. It's not that fast. I couldn't scroll down far enough to get it on screen, but it's 52 degrees per second. I is getting zeroed out. That is probably Acro Plus doing that. But it doesn't look like your sticks are deflected far enough to cause Acro Plus to kick in and fully zero the I term. So that's a little unusual. I term is getting zeroed a lot. Let's put RC command up here to just help make sense of this. So yeah. And I'm watching your gyro and looking for any kind of shake or shimmy. In fact, let's put the gyro down with RC command because we know that the gyro should roughly follow RC command. This will help us figure that out. And we can see that the gyro is roughly following RC command. Yeah. Not perfectly, but pretty close. It doesn't look like there's a lot of uncommanded like wobbles or anything. So your yaw axis looks okay, and your P on yaw looks fantastic. Your P on yaw has almost none of the sort of high frequency noise or anything that I might expect. Your yaw axis really looks quite good. So let's look at, since you gave me your pitch and your roll P and D gains, let's take a look at like your roll axis. D is non-existent. In this one, D is basically non-existent. It's got some surging in P. Again, I really want to look for, when you're doing something with yaw, to look for the shakes you're talking about. But I don't see any hard yaw moves in this. Here's some oscillating in P as you come out of this roll. So this is indicative of a P term that feels about right. These kind of strong moves here, strong moves in P after the end of a sharp move. D term could easily come up on roll. Yeah, so I can't say as I'm seeing what you're talking about just yet. Again, D is very low in this one. This is D equals 3, by the way, and P equals 1.4. We do see a little bit of surging here in the P, so the P is close to the right range. It seems like it could come up a little. So now let's go to the other example, the other end of the spectrum, 1.7 and 18, and 18 and 21. So we don't have an example of like a middling D. Here we've throttled up. So with a throttle of 1360, this is probably more activity than I would prefer to see on D, as you said. It's probably a little too active. So I kind of wish that I could see something in between 3 and 18. Yeah, you're right. I also agree that this is too much D gain on, yeah, way too much D gain on roll here as well. Let me pause the recording and dig back through this and see if I can find some sharp yaw moves to look for this oscillation you're looking for on yaw. So here's what I've done to try to zero in on your problem a little bit. I've got the yaw RC command up at the top, and I've got the gyros at the bottom, okay? And So this is telling us what you commanded, so we can look for the parts where you put in sharp yaw. And this is telling us what was actually happening, so we can look for these jitters that you're talking about. Now, here, you're definitely doing a strong yaw move, but you're also doing a very strong roll move. Ideally, I think I'd like to find maybe some kind of more pure yaw. I don't think we're going to find one, though, because I think this is the move you're doing. You're doing this type of move. So fine, that's what you're doing. Some kind of a pirouette turn, it looks like. In fact, now that I think about it, if you have a ton of, this is your QQ racer frame, and you have a ton of up tilt. So actually what's probably happening here is you look from the camera perspective like you're doing a flat pirouette. But in fact, because you have so much up tilt, there's a ton of roll mixed in as well. So this is probably the moves you're talking about. And I do notice these little jaggies here in the yaw gyro, which may be what you're talking about. And I see those jaggies every time. And I don't see those in the other gyro traces. Now, this is significant because the gyro is telling us what's actually happening to the copter. So we can look at the RC command and see what you're commanding, and we can look at the PIDs and see what the PID loop is asking the copter to do. But the gyro tells us what the copter is actually doing. And if we see these jaggies here, it definitely means that something is happening, is actually happening. So let's now focus in on this area, and let's put the yaw gyro up here and the yaw PIDs down here. So yeah, I'm trying to figure out, first of all, if it's related to the stair stepping of RC command. Now we would normally see that in the D term. I don't think it is, because we've got several stair steps here, but we don't have an equivalent number of gyro jags. But hang on. Let's do this. It's getting deep now. Now we'll know for sure. What I want to look is, let's even zoom that out a little. Up and up and down and up and down and up. Yeah, okay, so it's RC command here that is causing this shutter here in your gyro. There's RC command is stair stepped. The P term is acting, we're seeing that stair step come out in the P term. The stair step normally comes out in the D term, because the D term is the derivative of P, and in the moment where this stair step happens, error is infinite for that one time slice, and therefore error grows rapidly, P grows rapidly, and D grows very rapidly. So we normally don't see this come out in the P, but it seems like the P is high, yaw P gain is high enough that we're seeing this come out, because there's a very clear correspondence here between the RC command stair steps and the oscillations in the P term. Now, the other question is, is your yaw P, we see that all the time here when you do these strong moves. So this oscillation you're seeing, this shudder you're seeing when you do strong yaw moves, that's my conclusion as to what it is. It's RC command. The stair stepping of RC command is coming out in the P term. Now that's very surprising, though, because, oh yeah, it's every time. The rest of the time, it doesn't look like you have excess P gain. So that is interesting. Oh no, I got to get back to that spot. Where was it? There it was. I wonder, are you using S-bus or are you using CPPM? Let's take a look at the spacing of these stair steps, because that's going to be your sampling rate. And it's 4.8 to 4.827, 4.809. Let's call that 4.810 to 4.827, 4.83. That's a 20 millisecond stair step. I actually am not 100% sure what to make of that. Did you? Oh, there you go. X4R. Okay, great. So you are using S-Bus. It's interesting that's a 20 millisecond stair step because I think that the S-Bus spacing is like 9 to 11 milliseconds. So I can't really make any sense out of that. But there you go. Um, so what can you do? Well, if you're using CPVM, I would say go to S-Bus. It'll improve the sampling rate and therefore smooth out those stair steps, but that's not it. I could say reduce your yaw P gain, but your yaw P gain is about right. I don't know. Maybe it's high, and I just like here you raise the throttle all the way, and it's not really going bonkers. I don't see a lot of just general yaw moves except for these sharp moves you're doing, so it's a little hard to judge what's happening the rest of the time. Um, I'll tell you this though. The good news is you don't need to try and solve this problem with pitch and roll D or P gain because if we look at your gyros, we can see that roll is just smooth as glass and pitch is pretty smooth. This shudder you're seeing is almost certainly in the yaw gyro, in the yaw axis. So focus on tuning the yaw axis would be my recommendation. What can you do to try to tune this better? Well, you could turn on RC smoothing. I am pretty sure that RC smoothing is still supported. It is turned off by default, but I think it's still there. You could certainly turn on RC smoothing. That will add a small amount of latency to your control, but it will smooth out those stair steps and get rid of that. You could reduce your yaw P gain. We don't see oscillations that hard on yaw, even with RC command steps. So your yaw P gain, oh, look at this. Well, you gave me a command. Thank you for giving me the command line dump. I forgot that you gave me this. So first of all, RC smoothing is off. So you can try turning that on. It'll add a tiny bit of delay, but it will smooth out those stair steps. Okay, so that's a thing you can do. Your P gain is 3.6. You could try dropping that and see if the copter still feels sharp. Pay very close attention though to a sort of a vaguely sloppy feeling in turns where it feels like you have to push the copter into the turn more than you ought to. That's how I feel like low P on yaw starts to manifest, and it's subtle enough that it can be really easy to miss that you've gone into that zone. So be careful about that. But certainly reduce P on yaw would be the other thing I would try. There you go. Those are the two places I would go. We've definitely diagnosed the problem, and so don't bother trying to tune your pitch and your roll to get rid of it. That's not where the problem is, in my opinion. Reduce yaw P gain and or add RC smoothing. The final thing I want to say is I've never seen this happen on yaw oscillations like this. Now, I don't know for sure, but I don't think 3.6 is an exceptionally high P gain even for multi-Wii. But I'm a little out of touch with multi-Wii, so I'm not 100% sure. So I'm surprised that we're seeing this, and I wonder if this is some kind of a manifestation of the way that multi-Wii handles the yaw axis. Because I haven't seen this kind of oscillation on Rewrite or Lux Float. So, and I know that multi-Wii ignores the D term on the yaw axis. So this may be a multi-Wii specific manifestation. So anyway, if it is, congratulations, you found it. Said the doctor to the guy with the strange virus. Sorry. Anyway, hope that's all helpful and happy flying.